Hello, I'm Yang. Today I'm going to talk about the evaluation of different schemes on OFDMA resource allocation. First, let me talk about the advantage of OFDM. So why we choose to use OFDM? First, it make a more efficient use of the spectrum. Um, so it allows some overlap between the spectrum. It make more use of the spectrum. Second, it is resistant to the frequency selective fading. This means by dividing the channel into the narrow flattening, flat fading bands, it can resist to the frequency selective fading. The third one is that it eliminates intersymbol interference. So by saying the word very slowly, for example, go Gators, it has the time it has the time to for the ripples to fade out. So after this ripple fade out, it will not interfere with the symbols nearby. The fourth one is that the channel equalization becomes simpler. So we don't need to use the adaptive equalization techniques that we used to use in a single carrier system. Before we going on to evaluate the OFDM resource allocation, let me talk about the channels. Since the OFDM also use the wireless channel, so we need to understand the characteristic and we need to simulate the channel condition. So there are several reasons that can affect the propagation signals. The first one is the multipass effects. So the radio signals can reach to the receivers through multipasses. For example, in this graph, pass one is a direct pass that base station direct pass the signal to the antenna, uh, receive antenna. But in the urban area, uh, many times the signals may be bounced back in the buildings, trees, and something like very large objects. So in this case, there are one direct pass and two bounce back passes from the buildings. This will result in the signals that arrive from the antenna, arrive at the antenna with different delays and with random angle variance. So these add together sometimes can uh, enhance the signals, but we have very high possibilities that we will experience a accuracy. So the signal we receive will be very fluctuate. Another problem is that we may experience the Doppler effect. Um, so the mobile stations, for example, when we receive a call in a train or in a car, we are moving on a very high speed. The change of the frequency, so it can change the frequency from the base station to our cars. So when we receive the signals, the frequency may not be the same as the one that transmitted from the base station. So we have the time horizon, and we experience high fluctuates. So how we simulate the Doppler effects in a small scale fading. There were basically there were two schemes. First one is that we generated two independent Gaussian noise and modulate it to the orthogonally to our carrier frequency. Then we add them together and pass them to a Doppler filter. Then we got this noise and experienced the Doppler effect channel. The second approach is that first we generate a Gaussian noise and first pass it to the filter, Gaussian to the Doppler filter, then move it or say we modulate it to our carrier frequency, and we get our uh, module model channels. However, this channel is not realistic because, as we said, the multipass effect so the signal may have random delays. So we need to add these delays to our models. In this graph, tap delays were added to form a more realistic channel. Now, when we have channels, let me talk about the schedule algorithm uh, of the OFDM, how they work, what the ideas, and what's the efficiency and throughput of the algorithm. The first algorithm I'm going to talk about the round robin, which is the most intuitive algorithm. So every user takes turns to access the resources, like the graph. Every color indicates users. So in every slot, each user takes turns to get the resources. In slot 1, the red user gets the whole resource. In the slot 2, the blue users get whole slot, and so on and so forth. This ensures the maximum fairness. However, it leads to a very low throughput of the system. As a second approach, I'm going to talk about the maximum rate. In this approach, the in this approach, uh, the base station only allocates the resources to the base to the mobile station when it has the maximum signal noise ratio. Then not the maximum, it has the best signal noise ratio to other than the other users. So uh, in this scenario, uh, the system can get the maximum throughput. However, it doesn't ignore the fact that the users may not be the same. Some users are very near the base station, and some users are far away from the base station. And so the users who are near the base station have always have experienced a very good uh, signals. So their SNR is very high, and the ones who are at the edge of the base station service cycle will have a very low SNR compared to the ones that are near the base station. So this leads to the unfairness in the scheme. You can see that in this graph, the red user is dominating the whole process, and the blue, green, and yellow are not. In the case, yellow is very little, only very limited. So they may have a starvation. This will not lead to a very good user experience. The third algorithm I'm going to talk about is called the proportional fairness. So instead of evaluating only based on the SNR, the base station allocates to the user to the resource allocate the resource to the users based on the average throughput within a certain time TC. So if at the moment the throughput is higher than the average throughput in the past TC, it will allocate the resource to the users. And you can see from the graph, it has more evenly distributed resource allocation. Uh, of course, it will compromise some of the throughput of the whole system, but it will lead to a more fairness is achieved. Now let me give me a demo of this project. So you can see from this graph that we have a very user-friendly interface. We can choose the central frequency, the velocity of the users, subchannels, and the TCs of the users. It also includes the type. We can have hill, urban, and flat areas. We have three algorithms. Also, we can use we can choose the different users. Uh, for example, we can have the first users have more gains. So the resource allocation will have experience a different scheme. When we click update, we can see the how the resource is allocated to different users. So in the round robin, it will like this, and in the maximum rate, you can see the red one is dominating, and the blue, green, and yellow ones are not. They are stuffed, uh, and and sometimes in some extreme case, they will not be served at all. This is my demo. Thank you very much.